Hey guys, going to pick up and finish the lesson with the quadratic formula. All right. Where we left off was talking about the discriminant. All right. The discriminant is b squared minus 4ac. All right. Discriminant is just a number. Okay. So it's the part of the quadratic formula that is underneath the square root. Okay. But it does not include the square root when you write the answer. All right. So what it tells us is what I mentioned at the end of class. It tells us the number and nature of solutions. Meaning, if you look at a quadratic, you can tell a quadratic equation based off what the discriminant is. You can tell whether there's going to be one solution or two solutions, and if they're going to be real or imaginary. Okay. So if from our examples that we did in class yesterday, the first example, we ended up with 64 underneath the square root. So 64 is our discriminant, all right? And we ended up, if you remember, with two real solutions. I think it was like 3 and -5, or -3 and +5, or 3 and -5. I forget which one, but it was two solutions and they were real numbers. They weren't imaginary. The second example, we got 144 minus 144, which is 0. So 0 is our discriminant. And that answer, we got one solution, right? There's only one because 0 is in the square root, so there's only one real solution. And our last one, underneath the radical, we had a -19. And we ended up with two solutions, but they were imaginary, okay? Now, these are the three types that you'll have. Either going to have two reals, two imaginaries, or one real. Okay. We will never, ever only have one imaginary. All right. It has to be two. And the reason is because the only way that we get an imaginary is by having a negative inside the square root. And when we're solving an equation, when you have a square root, it's always got to be plus or minus. All right. The only way you can have one real is if you get 0, because then there's no plus or minus. It's just 0. All right. It's not like plus or minus 8 plus something like that. All right. So we can say in general then, if the discriminant is positive, all right, anytime the discriminant is positive, we will always have two reals as our answer. All right. If the discriminant is 0, we will have one real solution. And if it is negative, all right, it will be two imaginaries. All right. So without even solving it, by just looking at the discriminant, we can tell those things. All right. Now, so an example here, find the discriminant and what information does it provide. So what I want you to do right now is answer for this one, 2x squared minus 5x plus 2. I want you to find the discriminant, and then based off of the discriminant, I want you to say whether it's two reals, one real, or two imaginaries. All right. I want you to try to do that for number 1 and for number 2. Try that right now. All right. Thanks. All right. So let's see how you did. All right. So remember, it's b squared minus 4ac. All right. My b is -5. So I square that and I get 25 minus 4 times a, which is 2, times c, which is 2. All right. So I get 4 times 2 is 8. 8 times 2 is 16. So I get 25 minus 16, which equals 9. All right. That equals 9. So that is positive. What does that mean? It is positive, which means that is two real solutions. So the answer is the discriminant is 9, which means I would end up with two real solutions. All right. Taking a look at 2. Once again, b squared minus 4ac. Notice I did not include the square root in the first one here. Same thing here. So b is -1. I square that, I get 1. Minus 4 times a, which is 4, times c, which is 5. 4 times 5 is 20. 20 times 4 is 80. So I get 1 minus 80, which is -79. That's my discriminant. It's negative, which means I have two imaginary solutions. So for ones where it says find the discriminant and say what number and nature of solutions you have. It just means, say, 2 imaginaries, 2 real, whatever it is. So you write down the discriminant and that information. Okay. All right. Now, one other thing that the discriminant tells us, it actually tells us whether you can factor a quadratic. All right, let's take a look at what this says. It says, let ax squared plus bx plus c be a quadratic polynomial with integral coefficients. That means that a, b, and c, they are integrals, okay, not fractions. And they have a GCF of 1, meaning you can't take anything else out of it. So once you have it, the GCF pulled out, greatest common factor pulled out, the quadratic polynomial is prime. Remember, prime means it cannot be factored if and only if the discriminant is not a perfect square. That means if it's a perfect square, so if the discriminant is a perfect square, that means the quadratic is factorable. All right. So if you get a perfect square as a discriminant, that means you should be able to factor it. If it's not a perfect square, that means it's prime. It cannot be factored. And in fact, if we look at the example we did here for the discriminant, we got 9. 9 is a perfect square, which means this should be factorable. And in fact, it is, right? 2x and x, put a 2 there and a 1 there. And if I put a negative and a negative, 2x times 2 is 4x, and x there, that gives me my 5x. 2 times 2 is 2 times 1 is 2, 1 times 2. If I FOIL this out, I get this, all right? In fact, it is factorable. So the discriminant will let us know whether something is factorable or not, all right? And that's based off of being a perfect square. So last type of example we need to do, can you factor this, all right? If so, factor completely. So the question is, I want you to find the discriminant, then based off of the discriminant, can it be factored? And if so, factor completely. All right. So what I would like you to do for each of these, find the discriminant, and then, so actually let's just do the first one again. All right. So if I find the discriminant, it's b squared. Let's write that, b squared minus 4ac. So b is -1, I get 1, square it. All right. Minus 4 times a, which is 6. C is -15. 15 times 6 is 90. 90 times 4 is 360. But a negative times a negative is a positive. So I get 1 plus 360, which is 361. Now, I don't know if you guys, hope you guys know this, but 361 is a perfect square. All right, 361 is 19 squared, which means, can this be factored? Yes, it can. And if so, factor completely. All right, so I need to be able to factor 6x squared minus x minus 15. All right, so we break that up, and I believe, if I remember, this should be what, like a 2x and 3x, I think works. And I think if I make this 3 and this 5, 2 times 5 is 10, and that's 9. So this needs to be this I think is negative. This is positive. That gives us negative 10x, right? Yep. And 9x, so we're good. So 2x plus 3, 3x minus 5. Now, if this wasn't a perfect square, we would just write prime. It cannot be factored. Okay, so you find the discriminant. If it can be factored, then you're supposed to factor completely. All right, go ahead and try these 2 examples doing exactly what we just did above. All right, let's see how we did. So b squared minus 4ac. So b is -3. Squared is going to give me 9 minus 4 times a, which is 5, times c, which is 2. Whoops. 20 times 2 is 40. I get 9 minus 40. So my discriminant is -31. All right. So since this is not obviously a perfect square, all right, this is what we call prime. It cannot be factored. All right. So you're done. All right, this one, b is -4 squared gives me 16, minus 4 times a, which is 4, times c, which is 1. I get 16 minus 16, which is 0. In this case, 0 is considered a perfect square. So this can be factored. So let's go ahead and factor it. And it's actually 2x and 1, 2x and 1. And it is a negative and a negative. So it's actually 2x minus 1, that quantity squared. All right. And since 0 is a discriminant, it means there would be one real solution if this was an equation. This was equal to 0. And we would see it would just be 1/2. All right. So the discriminant tells us how many solutions there would be, the type of solutions it would be, and if something is factorable. All right. So what I want you to do now for the rest of class is to go back and do the homework worksheet that we had from last night and do the rest of it. All right. You should be able to answer the rest of those questions and then finish as much as you can in class right now. And then then whatever you can't finish, you may submit sometime over the weekend to make sure you get in class by Monday for credit. All right. Hope you guys have a great weekend, and I'll talk to you guys on Monday.